Well, even if we don't need it, we can have at least a little heat shrink tubing uh, just to keep the cables together. And yeah, I think I won't bore you with the details. So from our voltmeter back here, we also need two connections to the binding posts, of course. Yeah, I cut that to size and yeah, come back to you. So yeah, the voltmeter is wired up to the binding posts and to its 5-volt power supply. So it's time to do a little test. Okay. 1, 2, 3, 4. Ooh! And since we wired up the voltmeter to the binding posts, what we have now is a totally overbuilt and probably very mediocre battery tester. Wow. Okay. Wiring up the ammeter. Okay, so the power supply for the ammeter should be long enough so if it's outside the case, yeah, just for maintenance purposes, it will go under here, the potentiometer for the current regulation. Enough room to put it, yeah, below the transformer so it's out of the way, and then up again, and yeah, right into the AC to DC break. Yeah, that looks good, and yeah, let me cut the cable. And I will, yeah, crimp the connector to it and put a little bit of heat shrink tubing around it, and yeah, then we continue with the next step. Okay, the power supply is going to the AC/DC board. Very nice. Now next step would be to, yeah, there's not a real good way to show it, but to go from the positive binding post out somehow to the negative input, negative side of the ammeter, because the ammeter is high side. So yeah, the positive input of the ammeter will be from the linear regulator itself, and yeah, the negative input of the ammeter or output will go to the positive binding post. Yeah, this is a little bit more tricky because it needs to go in there, and I want to leave too much wire, but also not too less wire. Yeah, I can always cut it shorter, but extending it would be a mess. So yeah, that should do it. Just marking it. Yeah, I cut it, tin it, and then we'll put it in. So I shortened the yellow cable, and I also connected that quite long red cable. Yeah, that is the positive output of the linear regulator. I already had that left from breadboarding. And now we can shove that, hopefully, without any problems, into the case. And now we can't, because the wires are in the way. Yeah, little problems. Okay, I have to get them off and reattach them when the instrument is actually in the case, but that means I don't need that yellow wire that long, huh? Do I? Okay, shit happens. So yeah, I didn't shorten the cable. I left a little bit space to, yeah, from your perspective you cannot see it, but I go around the pot for the current control and yeah, make a nice loop up here to the binding post. I also connected that cable, the positive output of the linear regulator, which obviously goes to my breadboard. Yeah, and I also, because the cables were already there, put in the voltage feedback. Also currently going to the breadboard from the binding posts to the linear regulator, and of course the ground to the breadboarded linear regulator. And yeah, it's really a mess getting the cables for the current measurement in while the instrument is inside. Yeah, but you cannot possibly have them connected, connect them while the instrument is on the outside and then get the instrument in. That's a little bit of a drawback of these Chinese panel meters, but they're nice and big, and therefore it's time to light up the Christmas tree again. So we already know that the whole thing works as a battery tester or as a mediocre voltmeter. But if I connect a load now, and I have of course a vintage color themed resistor for that, and then connect the battery. I'm trying not to block the instrument to the intended outputs of the linear regulator. Hey, we have a battery holder that displays as the current voltage and the current. Isn't it great? Yeah, it's just a bummer that the battery holder needs mains as a power supply, isn't it? Well, next stop, yeah, back here, the bridge rectifier. Well, next stop, I intended to wire up the bridge rectifier. However, as a last measure, I thought, okay, this is an old bridge rectifier from, yeah, the old insides, and as we all know, if you watch the teardown video with a little smoke, the whole thing failed. So one day I woke up and said, okay, let's test it. So this pin down here, or quick connect, spade connect down here, is an AC in. This is positive out. Ah, you see something? Can you see it? Yeah, I plugged it in the right way. So, yeah. Unfortunately, that diode is conductive in both directions. Well, and also this is AC, this is AC. It's conductive in both directions. This is AC, this is ground. Or minus, not ground. Not until we define its ground. It's not conducting at all. And from the other AC to positive, it's a dead short. And from that AC to ground, it's not conducting at all. So yeah, that thingy here is dead, and so we skip wiring up that thing, because it makes no sense wiring up that bridge rectifier. And we end this with some beauty shots. As I said, beauty shots. So we have the new front. Oh yeah, you have to ignore that. Okay, this is not the potentiometer that will go in. It will be a 10-turn type, like that one here. The new instruments, and yeah, everything lines up nicely, doesn't it? On the back we have the new IC power connector and the external fuse holder. That's a real advantage, isn't it? The new AC mains wiring, yeah, from the IC power connector, fuse holder to the switch. Also, yeah, looks quite good, doesn't it? And finally, the bridge rectifier in a more accessible, more prominent position back at the end, where the heat should dissipate. Well, dissipate, sorry. Not like before, where it was cranked somewhere down here. Heating the bottom and the rest of the case. Yeah. Okay, that was not so nice. Well, I guess that's it for today. And now, with all the wires coming out of the case, it's back to Yeah. Breadboarding the whole thing. Anyway, I'll keep you updated about the progress here, and at some point, it will be not next week, probably not next month, this I will have this working, hopefully, and yeah, on a circuit board, and then it can go in there, and I have a power supply again, which would be nice. Till then, bye.